My discussion is going to be more along the lines of an emerging technology that's in agriculture and forestry, and that's structural panels made from straw. Definitely nanotechnology is something that we are looking at as a benefactor in our work in the future, because like I say, I work very closely with Dr. Yaman Bullock, and we have a variety of different collaborations on the go, and so we're looking forward to seeing what's going to happen to nanotechnology in the future. For those of you who are not familiar with the panel manufacturing process, basically what we do, it's very simple. We take a raw material like wood or straw, we manipulate the geometry of the material, we'll apply a thermal setting binder to that material and either form the particles into a homogeneous mat, or perhaps we orient the particles in some fashion, press the panel under heat and pressure, then we'll produce a different product. There's 3 different classes of products that you normally are produced. One is particle board, similar to what you would see underneath this table. Second would be something like medium density fiberboard, a product that you'd see in crown moldings or in cabinetry, very fine, homogeneous, that accepts paints readily. And then finally we have our structural panels, and those are panels that are more macro-sized particles that are oriented specifically to create panels with very high stiffness to weight ratios, things that are used in the construction industry. Panels are very strong and stiff, but very lightweight and easy for people to manipulate in construction industry that don't require specifically specialized equipment to move. For those of you who know a little bit about the strawboard industry, I want to take time to talk a little bit about the past in strawboard industry, and talk a little bit about some of the things that have gone wrong in the past. Then I'd like to quickly talk about oriented split strawboard, the technology that we've developed. After that, I'd like to talk a little bit about China in 2010, and our company Panelboard Holdings, the licensee of the technology, and what they're doing in China, why they've gone to China, the challenges they're having in China, and what they're doing to meet those challenges. Firstly, back in about September 1999, that was the beginning of the strawboard gold rush. Isoboard was announced in about 4 years prior. They built a plant in Ely, Manitoba. The $140 million spent created a huge straw gold rush. About 30 projects were announced that were either going to be running or either being built or being run in the next few years, and everybody is really anticipating a boon in this industry. About 6 years later, Dow Chemical took over. Well, about 3 years prior to that, Dow Chemical took over and created Dow Polyboard. The plant closed its doors in December of 2005. By the time Dow Polyboard closed, there were no more strawboard plants being conducted in North America. They were either closed or the projects had been canceled. Fittingly, Dow was, the isoboard plant was the most technologically sophisticated and best equipped plant at the time, so it stayed open the longest and created actually a very good product. If we look at it forensically, what happened, there was multiple reasons for this failure. At the time, all the plants were making particle board. And making particle board out of straw is probably the technically most challenging thing you could do. When you're applying a thermal setting binder like an isocyanate to really small straw particles, and you're trying to form that into a mat and run it into a press at very high speeds, it doesn't work very well. Isocyanate has no tack, and essentially applying straw with isocyanate is like putting oil on ball bearings and trying to form it into a mat. Integrity of the mats don't hold, and you had a lot of production problems. In addition, most of the projects were highly undercapitalized. They had very small, older plants that they were trying to reconvert into making this technology work that could not compete with the modern plants. And then finally, the particle board market is flat. There's no room for premium products there. Isoboard created the best particle board in the world. It's probably one of the best particle boards ever made and probably will ever be made, but there was no premium for the product. The product had to compete against very low cost materials, and at that time was probably ahead of its time. Now it probably would have a little bit better chance of surviving, but back in those days there was no need for a high-tech particle board. Oh, pardon me. roughly about the same time as Isoboard opened, us at ARC, or now AITF, created what we call oriented split straw board. Now, contrary to popular opinion, this board was not produced to displace OSB. This was a product that was challenged by the OSB makers here in Alberta to help extend fiber supply. They came to us and said, well, you know, the way the OSB industry is going, if we keep going at this rate, we're going to run out of fiber soon. So they said, is there a way we can extend the fiber supply? And so we looked at the problem and basically came out and said, well, you know, yeah, we could use straw. We've got a lot of straw in the province. We can take this material. If we take straw, open the tube longitudinally, split it in wide open so we can apply the resins on all the surfaces, take that material, orient it with an OSB strand, we could make it work. So basically, we did that, set everything up, and away we went. Now this is a schematic showing basically how OSSB technology works. What we want to do is slice the straw longitudinally, maintain as much length as possible. Here we have a pair of rotating rollers. They're rotating in opposite directions. They're rotating in opposite speeds. They have grooves in them. The straw passes between the rollers. As the straw passes between the rollers, it creates a shearing effect. It shears the straw open and allows the tube to maintain as much length as possible. When we have that, we can apply the resins. We can orient it just the same way as a wood strand. This slide here illustrates why we need to maintain length. If we're looking at the, looking at the modulus, if we look at the modulus of rupture, we can see that we only need a particle about 12 millimeters long to make a structural panel that has the structural strength. If we want structural stiffness, however, we need a particle average length of roughly 40 millimeters long. And if we need that to create the stiffness, and of course get the proper strength to weight ratio that's compatible with OSB. Well, as times change, things do change. The technology was definitely considered by the OSB industry, but over time, things have changed and people have moved on to different technologies and different things. The OSB industry here in Alberta was looking at other business opportunities and looked away from Strawboard. So we had to go out and search for a new partner. We met a company called Panelboard Holdings from the Netherlands. They are a European-based company, and they decided, well, technology is really good, let's try something with it. So they decided we're going to go to China. So we went to China, created Leenderson Panelboard. The plant is a very small size plant in terms of panelboard capacity. It's about 80,000 cubic meters per year, or about 5,000 12 millimeter sheets per day of OSSB. Can't really show you the press because can't take pictures of it for some reason. I don't know why. So why did they go to China? Well, China really has all the conditions to accept this type of new product. Firstly, unprecedented rural modernization. 200 million homes needed in rural China in the next 25 years. Quite ambitious project to undertake. Looking for a variety of different building materials.